Hello everyone. In this video, I am going to show you how to use dynamic programming to find the longest common subsequence between two strings. So in this problem, the input is two string A of length n and B of length m. Okay, and we want to output the length of the longest common subsequence of A and B. Okay. So similar to the edit distance, the length of the longest common subsequence can also be used as a measure of how similar two strings are. Okay. So for example, let's say if so we have two strings. For example, A is equal to um, A G G T A B, okay, and B is say G X T X A Y B. Okay, so I just found this example online, but okay, so the longest common subsequence of these two strings is GTAB. Okay, so you can visualize the common subsequence as a matching that matches characters of A to similar characters of B, such that the relative ordering um, is preserved, right? So, okay. So how do we approach this problem using dynamic programming, right? So the idea is pretty simple. We defined the subproblem as follows. Okay, so let LCS ij be the length of the longest common subsequence of the prefix a1 up to ai and the prefix a1 up to bj. Okay. Okay. So how do we compute LCSij? So so let's handle the base cases first. Okay. So we have the following. LCS of 0j is equal to 0 because the longest common subsequence of an empty string and another string is the empty string. Okay, so the length of the empty string is 0. Similarly, LCS of I0 is also 0. Okay, so now we want to okay, so these are the base cases. Okay, so now we want to find the recursive structure of these subproblems. Um, okay, so let's visualize the problem like this. Okay, so we have A1, A2, dot AI minus 1, and then AI. Okay, um, and below we have B1, B2, dot Bj minus 1, and Bj. Okay, so if okay, so okay, so if AI is equal to Bj, okay, then we can match AI with Bj. Okay, so like this. Okay, because otherwise, now let's say if we if we don't match AI with BJ, but we match AI with something else, right? Over here, for example, right? Then it doesn't matter, right? So we can replace this with by matching AI with BJ, and we still have the same common subsequence. Okay, so so then we'll have that the longest common subsequence would be okay, and it doesn't make sense to not it doesn't make sense to ignore both AI and BJ, right? Because then we would have we would waste a common character. Okay, so the longest common subsequence is basically obtained by matching AI and BJ. Okay, and then we find the longest common subsequence between the suffix a1 up to ai minus 1 and b1 up to bj minus 1. Okay, so in this case, LCS ij is equal to 1. Okay, because uh, that takes the matching of AI and BJ into account. Okay, thus the length of the longest common subsequence of the two prefix a1 up to ai minus 1 and b1 up to bj minus 1. Okay. Okay. So on the other hand, if ai is not equal to bj, okay, then we cannot have both ai and bj in the longest common subsequence, because in that case the last two characters of the common subsequence don't match, and that wouldn't be a common subsequence, right? So in that case, we have to either omit AI or BJ, right? Um, so so the longest common subsequence must either omit AI or it must omit BJ, right? So in that case, we will have LCS IJ is equal to, so we have two cases. If we omit AI, then we would have LCS of A1 up to AI minus 1. Right? So it's like this. Um, so then the LCS, the longest common subsequence of um, uh, the prefix AI to AI, A1 up to AI and B1 up to BJ. If we have to omit AI, it would be the same as the longest common subsequence of AI up to AI minus 1 and B1 up to BJ. Okay. If the longest common subsequence omit BJ, right, then it must be the same as the longest common subsequence of A1 up to AI and B1 up to BJ minus 1. Okay, but we don't know for sure that, with which one the longest common subsequence omits, right? So of course, we look into both of these cases, and we take the one that has that is longer, right? So because we are trying to find the longest common subsequence. Okay, so again, so we have this rule, all right? Okay, so what does the algorithm looks like in general, right? So we can have the for loop for I from 0, 1, 2, dot, dot, to n, for j from 0, 1, 2, dot, dot, up to m. Okay, so if I is equal to 0 or j is equal to 0, then LCS ij would be 0. That's the base case. Otherwise, okay, we have two subcases. If AI is equal to BJ, right, then and from the above, right, we know that we might as well match AI with BJ. Okay, that counts as 1 toward the length of the longest common subsequence. Right? So LCS ij would be 1 for the one there counts the matching between AI and BJ, plus the LCS between A1 up to AI minus 1 and B1 up to BJ minus 1. Okay. Otherwise, right, then we know that the longest common subsequence between A1 up to AI and B1 up to BJ must omit either AI or BJ, right? So the LCS of AI, the LCS of I and J is equal to the maximum between LCS of I minus 1 comma J and LCS of I comma j minus 1. Okay. Okay, so in the end we output LCS of n comma m, which is the length of the longest common subsequence of two original strings a and b. Okay, so let me show you a my implementation of the pseudocode on the lead code. Okay, um, so um, okay, so here's the my source code, right, which is very similar to the pseudocode itself, right? So I set n to and m to be the length of the two input string text1 and text2. Okay, I prefer to work with indexing starting at 1, so I add to the me space in the beginning. Okay, and here's the LCS is the dynamic programming table. Okay. And I fill the table just like I did in the pseudocode. Okay, and I return um, the entry n and m of the table. Okay, and um, you know, so the algorithm runs uh, correctly, which is nice. Okay, so that could be it for this video. I hope you tune in for other ones too. Okay, so please subscribe and help me grow the channel. Thank you very much.